Great to be here. Really good to see that there are a lot of Bitcoin people who are interested in Nix. Maybe there are even some Nix people interested in Bitcoin as well. I'm very much looking forward to the discussion and the talks and the hacks tomorrow. And a big thank you to Lisa and the bitcoinconf team for putting this together. I'm very excited. I'm going to talk about nix-bitcoin. What is it? How does it relate to NixOS? What features does it have? What are the weaknesses? What is the vision? Yeah, let's start with what is nix-bitcoin, at least according to the README. According to the README, nix-bitcoin is a collection of Nix packages and NixOS modules for easily installing full-featured Bitcoin nodes with an emphasis on security. Nix-bitcoin can be used for personal or merchant wallets, public infrastructure, or for Bitcoin application backends. Most people today, I think, they're using nix-bitcoin as their personal Bitcoin nodes. And if you use it that way, it's somewhat similar in the functionality as a Raspberry Blitz, Umbrel, Nodl, etc. So at the top, you see a picture of a personal Bitcoin node of mine, a former personal Bitcoin node of mine. Don't worry, I have a rack now. All right, let's go a little bit into history of this project. So this guy is an absolute hero of Bitcoin. He's not that well known. This is Russell O'Connor. Among many other things he did, in 2012, he prevented the op-eval soft fork being merged into Bitcoin by Gavin Andreessen, which would have allowed for infinite recursion and therefore DOSing the Bitcoin protocol and all the Bitcoin nodes. Out of that, we got P2SH instead. He's also the reason, or one of the main reasons, why we have Taproot today. He came up with this whole idea of this speedy trial activation method, and he championed it. He's the inventor of simplicity, and in 2016 he gave a talk at a Blockstream offsite about NixOS, since he has been a NixOS user for a long time. And in 2017, I looked at all these Lightning nodes in testnet, and I realized, okay, this is really annoying. Now I have to set up Bitcoin nodes again. I've set up a lot of Bitcoin nodes in my life already for Liquid, etc. So maybe, is there not a way to make this more systematical? So I set this up only once, systematically and very nice, and then I can just reuse that. And then I remembered Russell's presentation. I thought, maybe I should play around with NixOS a little bit. And then November 13th, 2018, I made the very first commit in that project. Apparently, I got Bitcoin running. I want to talk about a little bit about the contributors as well. So the first contributor was bitcoindev. He's unfortunately not around anymore, but he was really instrumental in shaping our focus towards this privacy and security aspect. And another extremely important contributor, he's still around today, if not the most important contributor, that's Eric Arfstead. He's an incredible software engineer, really reliable guy. I'm very happy that we have him. And he's a Nix wizard par excellence. He showed me that there are levels to this Nix game that I will never be able to comprehend. I doubt it. All right, and the first time we used nix-bitcoin really in production was in this game called Bitcoin Bounty Hunt. It doesn't exist anymore, unfortunately, but it had this crazy game. Crazy incentive structure with Lightning, and you could buy in-game ads, and one of them you see here, that's our nix-bitcoin logo. And that's where we kind of used nix-bitcoin for the first time in production. So in order to get a sense of what nix-bitcoin users think about nix-bitcoin, I went onto Twitter and looked for a few tweets. So for example, found nix-bitcoin.org recently, and it's really cool, quite different from any other Linux distro and package manager I've ever used, but damn clean. Tried many node setups, but nix-bitcoin.org is the one that best fits my needs. Highly configurable with security by default, and maintainers are very helpful. Send a small donation to the BTC Pay server and will continue to as I keep value from the project. Set up a nix-bitcoin node after listening. It's a bit more technical than Raspberry Blitz for OS setup IMO, but feels more minimal, locked down to only what I enabled. Definitely need mempool module though. Nix-bitcoin.org is an awesome integration of Bitcoin Core, Liquid, Core Lightning, LND, and Tor. After Bitcoin Core, nix-bitcoin is the most important project in Bitcoin. I think that's a bit of an exaggeration, to be honest. Reproducible builds and deployments, exactly what we should expect from all nodes. So why is it damn clean, configurable, secure by default, minimal, and reproducible? Well, one reason is that these are the values that the contributors find important, but it's also one crucial reason is that we built this whole thing on NixOS. So we've talked a lot about NixOS already in the morning, but just as a reminder, here is sort of a short description of NixOS from the NixOS docs. So NixOS is a Linux distribution based on the Nix package manager and build system. It supports reproducible and declarative system-wide configuration management, as well as atomic upgrades and rollbacks. Although it can additionally support imperative package and user management in NixOS, all components of the distribution, including the kernel, installed packages, and system configuration files, are built by Nix from pure functions called Nix expressions. So they mentioned system-wide config management. So how does that work in practice, at least for nix-bitcoin users? So you have some configuration.nix, that's a text file, and there may be other text files that are imported, and then you use the Nix tools to take this configuration and deploy it on some infrastructure. At least this is how most nix-bitcoin users use this. How does such a configuration.nix looks like? Stick gave an example of it earlier, so ignore, do you see my cursor by the way? No. Anyway, ignore the syntax and the details. You see there are some imports. It imports a hardware configuration. It enables OpenSSH. It sets a custom port for OpenSSH, and it configures a hidden service or onion service for OpenSSH. And then you run NixOS rebuild switch, and hopefully if everything goes well, you will have these things enabled on your machine, and only these things. So it's very easy, relatively easy to see what is currently going on a system by just looking at the configuration.nix and the imported files. So why is this cool? The whole system configuration is just a few text files. They can be kept under Git version control. So you have a history of what you've done. You can easily deploy a configuration to a different machine. We've talked about that as well. Nix expressions, they can be checked for well-formedness, which is really nice. If you make a typo like this, where the port is not really a number, then you will get an error at build time, which is pretty early compared to what often happens otherwise, where you start the service, you see it doesn't work, then you need to look into the logs and figure out what went wrong, whereas here you have a type checker who helps you figure out these mistakes early and thereby reducing the time for this feedback, develop, debug feedback loop. So let's give a little demo of the configuration.nix for nix-bitcoin. This, and here we are. I hope that's visible. Okay. All right, so again, ignore this, but you see there are some imports. So it imports a secure node preset from nix-bitcoin. And this file is the example configuration file that we ship. So if you install nix-bitcoin via our installation tutorials, you will have this file, and it tells you to look at these fixmes. So we have to look at those fixmes and sort of address them. So for example, here it tells you, well, we use this hardened kernel preset, and it pretty significantly impacts your performance, so turn this off if you don't need it. bunch of other stuff. It tells you you can enable modules by uncommenting their respective line. Bitcoind is enabled by default via the secure node preset. All right, so now if I want to set a custom option, for example, this pruning option, I can just do this. And I can also add additional options. They are all defined in the respective module. I can set turn on transact TX index, so like this. Bunch of other things. The C Lightning is enabled here. It does not, by default, accept incoming connections. If you want to do that, you have to enable this option. And then it will also set up a onion service for this, so your Core Lightning node is not available through ClearNet if you enable this option, only through Tor. You can also enable plugins. There's LND, which you can enable. There is Write the Lightning, Electros, Fulcrum, BTC Pay Server, Liquid, hardware wallet stuff, Lightning Loop, Lightning Pool, Join Market. There's a backups module that you can enable, NetNS isolation, we're going to talk about that. Here's another fix me, so you probably want to to set a custom host name. You also probably want to change your OpenSSH, this thing to your actual actual SSH public key. And here you can add some packages that you need in your system, for example. And yeah, that's mostly it. Then you can deploy this. You run, basically we explain how to deploy this to an actual machine. All right, let's get back to the presentation. Oh, nice. All right, we've talked about these things, but one of the most important things, to me at least, is this concept of abstraction. The configuration is not just some text file, as you've seen. It's written in a powerful language, the Nix language. And that means that we can use abstraction. We can write reusable software components, like modules, that have clearly defined interfaces, and they can be connected together. And to understand the context for why this is useful, we start with this example. So assume you have a Bitcoin node, you have a Bitcoin daemon running there on localhost, some port, you have a Lightning daemon running on localhost, some other port, and you have a Lightning wallet. These are all different processes. So what you want is that the Lightning wallet talks to the Lightning daemon. Usually it does that by connecting to localhost port M. But what the Lightning wallet can also do, it can try to connect to the Bitcoin daemon. There's no reason to do that. It's a Lightning wallet. It should only talk to the Lightning daemon. Maybe your Bitcoin node is set up such that it requires a password or whatever, and your password is strong. But ideally, what we want is that the Lightning wallet can never connect to the Bitcoin daemon or anything else that is on your system, only to the Lightning daemon. So the solution to that is to put every service in its own so-called network namespace. This is a Linux kernel feature. And what this means then for the services, it looks like they are all on sort of different machines even that are not connected at all. There's no cable, there's no switch between them. They are just like separate network interfaces. So we need to build an internal router that connects these namespaces. So we have a bunch of services. We need to connect them. And the risk is that we end up with spaghetti code. Because we have all these different requirements. This might end up with unstructured, hard to maintain code. Architecture resembles a tangled pile of spaghetti in a bowl. And we don't want that. The problem is that there is this inherent relationship between security and complexity. We might want to increase our security by adding these various rules to our system, who can talk to whom, etc. But this increases the complexity, and the complexity is poison for security, because within a complex system, we cannot understand what's going on. We cannot evaluate if there's security. We cannot review if an update will break security or keep it. So what we need to do is to make this dependency as weak as possible. And we try to solve this by using the Nix programming language and abstract away this complexity. We build simple components with clear interfaces, and we use these components to solve our problems bottom up. So this is an obvious concept for programmers, of course, but it's not that well known in the context of infrastructure, as far as I know. So we have a Bitcoin module. It talks to a network namespace module. It also talks to a Tor module that's responsible for managing the onion services. It has some systemd hardening component. It talks to a secrets module that's responsible for managing secrets like passwords. And it itself exposes some functionality via RPC, and the Lightning module then connects or uses this RPC functionality. So to summarize, we try to manage the complexity and then hopefully end up with a secure system instead of spaghetti code. Of course, spaghetti code can still happen, but at least we can try. It would be impossible to do if we were just dealing with text files, essentially, and did not have a programming language. Okay, let's talk a bit about reproducibility. So we've seen this before. We have this configuration.nix, additional text files. We use the Nix tools. And they also create a set of dependencies for us. And the whole system configuration, including the dependencies, is uniquely identified via some hash. So how does it look like? There is this run current system symlink, and that one points to a directory that represents our current system. And the format for the files in this Nix store is that first we have hash of dependencies, starts here xqwh something something, and then we have the name of the thing. And we can now try to follow this further down. So we can ask the Nix store, what does the current system depend on? Well, we see it depends on Linux 6.1.52 and some etc thing, whatever that is. So we follow that etc thing further, blah, 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 and then we finally find, okay, it depends on bitcoind 24.1. What does bitcoind depend on? Well, it depends on glibc, gcc, miniupc, blah, 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 blah. So we always know exactly what is running on our system. And this is great because it helps with debugging. We know what's on our system, and it also helps with identifying potentially malicious dependencies that we have on our system. We can also build all the dependencies from source to avoid trusting binary caches. Julian talked about Trustix earlier today. This tries to solve this problem that we have these binary caches that we need to trust. I'm going to talk about later why this is not that great. But what's important to know is that we won't necessarily produce the byte-for-byte identical binaries as everyone else. So there is this sort of different terminology that's floating around the Nix space and the Bitcoin space. In the Nix space, reproducibility means that if I build some sort of package, then I will always use the same sources to build it, and the same dependencies. Whereas in Bitcoin, when we talk about reproducibility, we usually mean byte for byte byte for byte reproducibility in the sense that it produces byte for byte identical binaries, which Nix or Nix packages don't necessarily do, but actually they almost do this. So 99.77% of the NixOS minimal ISO are already binary reproducible. So what the updates do, well, they essentially replace the run current system symlink, and nice thing is nix-bitcoin users, they all have the same packages as long as they're on the same version, and that makes updates less likely to break because they presumably didn't tamper with their system manually. And files that are not dependent on after update, we know what those files are, and they can be pruned. So we don't have old software running around. All right, the rollbacks feature was talked about also today. So this is, you're greeted with this screen if you, when you boot NixOS or some version of the screen. I think it's a very old version. What it allows you to do is to boot from previous configurations. So anytime you run this NixOS rebuild switch command, it will add an entry here. And if something goes wrong, you can reboot and then use one of these older configurations. So this gives you a peace of mind when updating. All right, so that was the whole NixOS block. Let's talk a little bit more about nix-bitcoin, some feature highlights. We have this run tests shell script that basically runs our test framework, and it runs these tests in a virtual machine. And if all tests succeed, it means that it's a bit of an exaggeration, but that nix-bitcoin is ready for release. So if the tests run, then it is very unlikely that something extremely bad breaks, because our tests, they're pretty thorough, they test a lot of stuff, and that helps us making rather rapid releases. We don't have release candidates or something like that, because so far we haven't really needed them. All right, this shell script is a bit more powerful because we can also run custom tests or test scenarios. So this is the most complicated one that we have, presumably. That's the C-Lightning replication test scenario. What it does, it starts two VMs, Core Lightning or C-Lightning running on one of them and trying to replicate all the state updates to the other one, and then later we check whether that actually worked. You can also run commands inside of a container that runs nix-bitcoin. So here we start the bitcoind scenario. We run the thing in a container, and we run a command, bitcoin CLI get info. And since this runs in a container, it's really fast, 1.5 seconds. And you can test custom test scenarios. Now it gets really interesting. Because here, so this scenario that we define here that was used in a to review a pull request. It enables C-Lightning. It sets C-Lightning to a custom port. It makes it such that C-Lightning accepts incoming connection through Tor, and it sets the external port to 9735. And then we run the command lightning CLI get info, and that shows that everything has worked. You can build really, really complicated test scenarios with that. And this really, really, if used correctly, this really helps with reviewing PRs, for example, because this makes bugs reproducible for us, which is usually pretty hard in infrastructure. And you can just check, okay, does this scenario exercise this faulty condition? Then check out the PR and then run this test scenario again, and then see that it hopefully the bug has gone away. And I believe this test framework is also the reason why we are sort of competitive with these other node projects, which seemingly have a bit more mindshare. We do it in our spare time. But this test framework really helps us with getting updates into nix-bitcoin and adding functionality. All right, we have this concept of examples. So this command, nix-run github:/nix/nix-bitcoin, can be run on any Linux machine that has Nix installed. Doesn't require NixOS. It requires Flakes, I think. And what it does, it starts a VM with NixOS installed and nix-bitcoin. So if you are a Linux user, you can quickly get some feeling for how it is to work inside a NixOS system and also run nix-bitcoin in that system. And you don't have to clone our repository or anything like that. But we also have examples in our repository. They are a bit more powerful, so this would start also an interactive VM, but the advantage would be that you could give it a custom configuration to play around. We also have a production-grade example, and that is nix-bitcoin.org. And nix-bitcoin.org, its configuration is fully open sourced on GitHub. It hosts the nix-bitcoin.org webpage. It has a custom BTC server-powered donation page. It has our Matrix home server. It's a Flakes-based configuration, and it follows best practices. Now let's get into some of the security features, some systemd hardening options that are interesting even to non-NixOS users. This should be interesting to any systemd users because this is really, really powerful. So for our default process configuration gives every process or every service a dedicated user as far as that's possible. And then there's this protect system strict option that makes it so that the file system is mounted, or almost the full file system is mounted read-only, and then we just selectively allow which directories or to which directories this particular service can write. In this case, this is just the data directory using this read-write paths option. We deny any IP by default, any IP communication except to localhost. Why do we do that? We do it as a defense in depth mechanism. If there is some, so we want that nix-bitcoin is private by default, and we do this such that even if there is some sort of misconfiguration, the service will just stop communicating, but it won't accidentally communicate through ClearNet, which would be the worst case. So in order to communicate to Tor, through Tor, the service just needs to talk to localhost, which is pretty nice. We enable Tor by default, and we have some more fine-grained controls to turn on or turn off Tor, and or run ClearNet in parallel. We have a bunch more of systemd hardening options that we use, in particular this network namespace path if this netNS feature is enabled, which it is not by default. Some best practices for bitcoind hardening. So bitcoind has this concept of a whitelist. And so you can set a whitelist for a particular user, and that means that only the RPC commands in that whitelist are going to be accepted. Everything else is going to be rejected. And what we do is we define an RPC user we call public, and that is only allowed to use read-only commands. It's useful, for example, for BTC Pay Server, because BTC Pay Server needs access to bitcoind. But using this public user, it can only access, or it can only run read-only commands. It doesn't have to access the wallet. So even if the BTC Pay Server is compromised, it cannot access the bitcoind wallet. We also have a relatively well-defined and well-funded security bounty fund. It's a 2 of 3 multisig. It's pretty special in that it covers certain dependencies of nix-bitcoin, even if they, so it covers certain dependencies of nix-bitcoin if they don't have their own bug bounty program. So if they don't, then it's covered by our bug bounty program. No payout so far in the 18 months since inception, but I would definitely support if more people want to look at this and try to claim this reward, as long as they do it responsibly, of course. We have this concept of extension modules. So it's possible to extend nix-bitcoin with modules that are maintained outside of the nix-bitcoin repository, and they have their own review and release process. And the reason for this is that it removes the reliance on the nix-bitcoin maintainers as gatekeepers. You don't need to convince us that it's worth merging your module. and a module could start out as an extension module and thereby prove that it works and that there's demand for it, and then it could graduate to a proper module. And we built this extension module feature such that extension modules can use the nix-bitcoin libraries, they can use our modules, and they can hook into the nix-bitcoin test framework and be tested within our test framework. All right, let's get to the weaknesses. The main weakness is that advanced configuration requires knowing Nix, and learning Nix is hard or even very hard. So if you follow our guides and if you just turn on and off the options we provide, then I think it's pretty straightforward to use nix-bitcoin. But as soon as you do anything out of the ordinary, it can get hard very, very quickly. And that's why we call nix-bitcoin the low time preference choice among the node distributions. Somewhat aligned to Bitcoin philosophically, you have to make an investment now, and hopefully you will reap the rewards rather long in the future. But we claim it's worth it. Another big problem, I can only give a high overview, a very high-level overview of this, is supply chain integrity is really insufficient. So assume you have your nix-bitcoin node running, and you receive updates from the nix-bitcoin project. They are signed by me, and your node is automatically verifying these signatures. But for all the packages and modules that we do not maintain, we receive the updates from the Nix packages. And as you've seen in Stick's graph, it's a giant repository with tons of people who have commit access. It must be in the hundreds. I don't know actually what the number is or how to actually figure out what the exact number is. And this is great to keep the packages up to date and add new packages, but security-wise, it's a bit of a problem. There are no signatures or anything sophisticated. A malicious committer could just try to add malware, and hopefully he's caught while doing that. I have some heuristics, some automated tools to try and detect malicious changes to software, but it's very, very, there are holes in this, let's say it like that. I don't want to go into it. Security by obscurity. All right, and then the other problem, binary cache. Julian talked about it. Even if the sources the nodes get and all the derivations, if they are fine, most nodes download binaries from some centralized binary cache, and a malicious binary cache could just serve you malware. You can build from source, it's possible. I do this, but this breaks the builds very often. You would have to use this substitute equals false option. Why does this break? Well, it downloads something from the internet. It downloads a lot of stuff from the internet, and the internet is very unreliable in keeping stuff at URL. So sometimes you just get a 404, the thing that is not there anymore, or the person who originally uploaded this also updated it, which changes the hashes, and then you have to manually check what's going on and review this. So unfortunately, this breaks way too often. I think my optimistic take is I think these problems can be addressed. Like the Nix community is really large these days, and a lot of people care about exactly these problems. And it's also great to see that the Nix community is growing, and I hope we can make progress on this. For example, Trustix, and there are a lot of other proposals in this space, hopefully improving the Nix documentation, maybe I don't know, ChatGPT assistants will be able to help you much better in writing proper Nix. It already helps me quite a bit, to be honest. So what's our vision? Our main priority is to keep nix-bitcoin up to date with patches, minimal, low maintenance, reliable, and extensible. And if you refer back to the tweets I showed in the beginning, this is also what the users want. We are also open to adding new packages and modules for new software projects under a few conditions. So a new dependency, of course, shouldn't have a crazy build system, make it not too hard for us. There's reasonable demand from users to add it. There's a reason to believe that the new dependency is being maintained in the future. This is almost the most important condition. There is a reliable volunteer who maintains the new nix-bitcoin code. Because there are some people, they want to add stuff to nix-bitcoin, and then they vanish, and they will never look at this particular code again, and then we have to deal with it if something goes wrong. Nix-bitcoin is highly customizable and extensible. So my approach, at least, is not to force it into a certain direction, but rather see how it's going to be used. And then react to that. So, for example, there's been the talk for a long time that maybe someone makes a user-friendly node distribution that's based on nix-bitcoin, that adds some graphical user interface, something like that. This nix-bitcoin would be suited for such a project. All right, some short-term goals, since there's the hackathon tomorrow, and also maybe to give you a taste on what we are working on right now. It's like we need to improve the nix-bitcoin installation tutorials. People use these tutorials, they install their nodes, and then they never need to look at it again, which means they get out of date and they're not as great as they could be, and we are missing a lot of the modern stuff that you could actually do to simplify this. We need a proper logo. We need to add Signet support, that's highly requested. We have a PR that adds a mempool module. Maybe add something new, like a Fediman server module. That would be nice. I think nix-bitcoin is well suited for that. And that brings us to the end of the presentation. You can find the slides at nikla.ninja/slides/2023 btcpp PDF. That's all I had to say. Thank you.
Well, we had about 5 minutes for questions, if anyone's got any questions.
You mentioned that you use the user and group options in your systemd profiles. I'm just wondering if that was a deliberate choice, and what do you think about dynamic user?
Yes, that was a deliberate choice, but I don't remember the reason for it anymore.
Okay.
That was a rather long time ago. But yeah, what you're referring to is this dynamic user concept, right? Where like systemd automatically creates a home directory also, and like dynamically sets up a user. I don't remember exactly why we don't do that, but I suppose it has reasons. Pretty sure.
Sure. Okay.
Wait for the mic, please.
Oh, yeah, you can just go to nikla.ninja/slides if you want to check out the slides. A bunch of more slides.
I've been handed the mic to say it louder. Thank you for being the first presenter who actually gave the URI for the slides.
Yep.
Hi there. Thanks very much for your work. Can you give us a quick high-level view how you manage the data, like all the data all the services are using, how they survive an update, if I update services, and how does it work if I go back to an earlier kind of configuration of my system with a lower LND, for example, and then my data already has migrated to a kind of higher version. So how do you handle those kinds of situations?
I think the mutable state works exactly or relatively similar to a normal Linux system. So we have these data directories, a dedicated one for each service, and that's where the mutable state lives. And the problem that you refer to when you say, okay, there's this problem that you update something and it will update a database. It will do a database migration, and then you will try to go back to a previous configuration, and now the database has already updated, right? That's the problem you refer to. And I'm not aware of a solution to this. So Nix, as far as I know, Nix doesn't help you with that. Jim? Oh, okay. I think he had a response.
I'll say that nix-bitcoin does define your backups for you. So to the degree, remember that nix-bitcoin does supply some scripts, some infrastructure for helping you maintain your backups, which is actually pretty flexible. So as any sysadmin knows, before you do upgrades, you're going to want to back up your database schema and contents so that you can roll back the data in cases where that is not enabled by the software that you're doing. So more or less, that's a place where you'd use your backups, is my opinion.
Yeah, makes sense.
Jonas, I know there's an issue open on the repo for making options more discoverable. Like NixOS has the search slash options that allows you to see all the options in a package. I wonder if you guys had any ideas of whether you're interested in making that happen or.
Right. So I'll give a bit more context. I showed you the configuration.nix file, and there are very few options already there, and there are very few options, but there are much more options that we actually support. How do you know which options do we support? And the fastest method for me, at least, is to look into the source code and look at the options that we define. Now the question is, how can we make this more discoverable? I think is that issue still open? Okay, because I think it works now. It should be possible to search through this, using this search.nixOS thing, this online search, to search through nix-bitcoin options. At least it worked at some point. Maybe it broke. But what would be preferable, in my opinion, is to just have a man page for it. Like there's this man page for NixOS options in general, and it's very, very useful. You can quickly search through it. I want the same man page for nix-bitcoin. There was some work on it. I don't remember. It was some time ago what happened there. But ideally, we would have a man page. Online search sucks just for finding options, I think.
My question is just like how many, do you plan on like upstreaming anything to Nix packages, or are most of the hardening stuff like too opinionated for mainstream audiences?
I think the modules are not really well suited for upstreaming to the Nix packages. The packages may be, but I'm not sure. I mean, if there are people who want to maintain the Nix package in the Nix package repository, then I'm happy with removing it from nix-bitcoin. Let's say like that. But I'm not going to do it myself. It seems easier for me to maintain the packages in nix-bitcoin.
Just to follow up on that, does Nix packages have modules? Would it even be theoretically possible to just move nix-bitcoin into Nix packages?
The Nix packages, yeah, they have modules. I showed the OpenSSH module. There are tons and tons of modules. But the nix-bitcoin modules, I mean, they use the nix-bitcoin libraries and the nix-bitcoin functionalities, like this onion service manager, the secrets manager. They are pretty nix-bitcoin specific. I think it would be quite hard to untangle this. And I don't think there's a big advantage to adding it to the Nix packages. I don't feel like having a giant repository has some advantages, but it seems like there's at least some effort to try to spread this out a little bit, this big repository by this flakes, for example. Make it so that you can compose expressions much better than you could today, and not only rely on this single Nix packages, which is like this giant repository.
So if we're going to to add something like Fedimint, for example, so we've got so there's a Nix package for Fedimint. We've also got a flake. Is nix-bitcoin opinionated in what the better way to do integrations is, if I wanted to add Fedimint, for example?
So, but what would be nice to add to NixBitcoin would be a module, right? And we could just use the packages that you provide or the flake or whatever. But a module that uses then the NixBitcoin, bitcoind, and maybe allows you to also set up a Lightning Gateway and stuff like that.
Anyone else?
Great. Thanks again, Jonas.
Thank you.
Another round of applause.